Okay. Today I am going to do a thing I've been waiting to for quite a while, which is write a tool, a code generator that takes my live coding language in, and rather than construct a dynamic DSP graph at runtime, it outputs Rust code in my lower level, higher performance world. Which can then be compiled and much more deeply optimized than the dynamic graph can be, and will, I hope, allow me to make more complex stuff that is still performant. Ideally, be able to build the entire soundscape for like an interactive thing and run it on a single core or a mobile device, because that would be awesome. So this is almost certainly going to be several videos, because this is a fairly large project, and I haven't done a lot of advanced planning, so I don't really know how I'm going to do it. Although I don't think it shouldn't be that complicated. Although I think one of the more complex bits is going to be able to build like a build chain around it. So I'll have to have a build script of some sort that like emits the files. I don't know. That I've never actually done with Rust, so that'll be its own adventure. But right now I'm just going to try and build the code generator itself. That's my first step, and then I'll worry about the build chain stuff later. So I did a little bit of preparatory work for this, and if you have watched previous videos from me, you will be used to seeing, let's find a good example. Soft clip works. You'll be used to seeing my node definitions. So this stuff, this defines a very simple soft clipping limiter. And previously I had this custom value type that was like a tuple of arbitrary input values that could be routed into this node from a previous node, and then a similar one for the output. And I've changed that to simplify a bunch of stuff. So now my nodes, instead of taking a tuple of arbitrary types and then me having to write a bunch of mechanism behind that to like do all the stuff that needs to do, I am saying that nodes take an arbitrarily sized array of 8 wide F32s. So this is my standard SIMD block. And then in the type, I can specify how many inputs and how many outputs. So this one has 2 input ports and 2 output ports. My looper has 4 input ports and 2 output ports. And I'm using generic array to do this, and it uses type num as its compile time length indicator. So that's what these U2 are, an unsized integer with value 2 as a type rather than as a value. And then behind the scenes, that's used to set up all the relationships between these things, and it lets me check. Not that I've got the ports hooked up correctly, but at least that I have the right number of ports hooked up, and I can do that at compile time, which is nice. Okay, and then I have this type ports, which takes one generic parameter that is one of these type num integers that says how many ports. And this is just a type alias for a generic array of F32 X8s of this length. It's just a little bit more convenient to type than that full type. And that's basically everything that changed. I did a little bit of juggling to sort of arrange that. But other than that, things are basically the same. And it makes my inputs and outputs, I think, more sensible. I don't know. Like, rather than this rather complex packing and unpacking I had to do with the values, they're just arrays. And then generic array provides this macro for building a thing. It's a little bit ugly because I have to specify this type, and in my case, that type will always be the same. So I might build a sugar macro around this that just deletes that. But whatever, that's fine. For now it works. Okay, so now, so that's my background work. I wanted to do that before I started doing any code generation because I just knew a bunch of stuff was going to change. Having done that, now I can go into this stuff. I'm sorry, not that. This stuff. Okay, so this is my dynamic, my existing implementation of the dynamic runtime stuff, and this has all the mechanism for parsing my live coding language. So this stuff, and I'm going to use this same mechanism in my code generator because it's the same parser. And I just need to figure out what additional information I need to carry in order to actually do the code generation. So that's one part. And then where is it? This guy. This is the method that currently takes the output of that parser, which is a vec of these line thingies, which are, they represent the structure of the input code. And it outputs, or it configures a graph to be the graph described in that file. And this is where most of the actual instantiation of nodes happens, is in this code. Unfortunately, I mixed my logic a little bit when I first set this up, and sometimes stuff gets instantiated here. And I may need to change that. And that only affects the more complex, non-standard things like my pattern sequencers, which have weird additional syntax and logic attached to them. So I'm gonna have to rework those a little bit, I think. Yeah. So, but ideally, what I can do is I can take that line thing, which is this enum, and I can take a vec of these guys and take that and emit my code from that. So I want basically all the information necessary for the code generator should be in this structure. And I think that's going to be pretty easy to do. The exception is this one. And this is the case, if this option is sum, is where I've constructed a node during parsing. And that's the thing I'm worried about. So let's see if I can find an example of that. Here, probably. Yeah. So here in this case where I'm making my bridges. So these are my cycle breaking one sample delay lines that I use. And to do that, I have to build a matched set of arcs that have my data in them, so that they can communicate with each other. And so I have to make this pair of things that know about each other by calling this function. And so if I'm going to not do that here, then I need to basically make some way of putting this pair of nodes into my line list of lines such that I know they should be linked to each other, rather than creating that linkage here and then just storing those paired arcs. Or I need to be able to generate the code from this boxed thing. And I think that's going to be harder. And the reason I think that's going to be harder is because the way I normally do this, let's find another example. Where I am. Okay, here. So here I'm building a constant. And so you can see that I'm not pre-building the node because there's nothing in this option. All I'm saying is I need a node of this type, and C is my constant. And so this is my happy case, because down here I have a macro that tells me what it means for something to be AC. And in this case, it's my identity node, because that's just the way I do the constants. But and you can see most of these are pretty simple. It's like, the default version of some struct, or sometimes there's a constructor. Some of them are a little more complicated. But all of these things have basically, like, this is a macro. That macro knows what code needs to be run to make this node already, right? So, like, I should be able to take this macro and just, like, re-emit that highlighted bit as a string in my code generator, and I'm golden, right? That should just work. So that's why I think this isn't super hard. But when I go back up here and I've got these cases where I'm pre-building the nodes, I need to fix that. So, and then I have to figure out how to wire all this stuff together with the topology of patches that I define. And that's going to be a little bit tricky too, because the way I do the connections between nodes in the dynamic graph is in a lot of ways more flexible than what I do in the lower level one. One of the reasons it's slower is it has that extra flexibility, because every node basically writes its output to a store, and then reads its input from the store, and then I topo sort them and just do them in order, so that those things get shuffled in and out in the right sequence. And so there's all that, like, in and out of the store, which is where most of the performance, or part of the performance, comes from. The other part of the performance problem there is, like, those nodes are totally disconnected from each other. In the more streamlined version, a lot of that code actually should get inlined, and then I get several nodes sort of inlined together, at which point they can be optimized in a way that you can't do in the dynamic version. So I want to make that happen. But then I have to figure out some way of, like, arranging these things in such a way that represents that same, like, database. It's not really a database, but, like, a cloud of registers oriented structure that I've got in the dynamic version. So it won't be too bad, but it's just some figuring. There's going to be some places where I need to figure out, like, how to handle sort of duplicate nodes, which the dynamic version actually does pretty gracefully. It's a little bit trickier in the lower level. Okay, that was a lot of talking. Okay, but I still have this question of how do I deal with nodes that are pre-constructed. I kind of want to just never do that. So let's look at all the cases where I do it. Okay. All right. So here I am constructing a constant. These are a slightly different constant than the constant that's just C, which I don't know. The difference is not actually that interesting in this case, but and so the reason why I am constructing the node rather than just saying which constructor to use is because I have this parameter. And that may actually be the general case of just, like, I need to do this in cases where I have a parameter, a build time or a compilation time parameter, not a patch, a modulation source. But that's not too bad, because, like, I can handle that by just basically, because those parameters are always going to be floats. I think I can make that true, if it's not already. And so I could, if that's actually my common case, then I should be able to just replace this whole thing with a of floats, in this case, one long. And then I just know when I construct a constant, it takes those parameters in. And then I can do the same thing in the code generator. Okay. I hope that's true. Because I think that actually would be a step towards solving a long-standing problem that I have with the dynamic, the live coding language, which is that I don't have a good way of specifying parameters that are not modulations. And in a lot of cases, that's extremely awkward. So like an example would be my quantizer. I don't have a way to type the scale that I wanted to quantize to in the live coding language. I have to predefine that scale in Rust, compile the program, and then reference it in the live coding language. And that's just, it's a bad interaction. It's not the way it should be. So this might actually let me fix it. So that would be nice. So let's look at other examples. So in this case, I am building one of my automation things. So this is just a value that changes over time based on a sequence of interpolations between values. So that is, again, the same case. I've got some parameters that I need to pass into the node. But those parameters are not just floating point numbers. It's more complex than that. So that's a little more complicated. I need to think about that. The num sequencer it's exactly the same case. I'm taking in like my sequence pattern representation, which is just an enum of a subsequence enum that I've parsed out of the live coding language. But again, not just a floating point number. It's a more complex thing. I guess those were two different sequencers, but they've got basically the same structure. And here's that bridge where I have this pair that I need to make. Okay, so I guess that's a completely separate case. It's not that there's a parameter; it's that I have two nodes, but those nodes have to be constructed together. And in some of these cases, like in this case, like I might just consider making a new variant here that's like bridge node and is just structured a little bit differently, and then have special handling for that. I'm not sad about that. For the pattern stuff, I would kind of like to have a consistent handling. Okay, so now I've gone back to the top. So those are my cases. So what can I do there? So my two cases are the bridges. I'm happy special casing that. So that'll just be a new node type, bridge node. And that is a solution I'm fine with. So that's basically trivial. I have to write the code, but it's easy. And then the other case is where I have parameters, but sort of arbitrary parameters. I don't really know what they're going to be. And I need to handle those somehow. So the simplest solution might be to have basically a num of parameter types. So I have like these pattern sequences and the automation sequences, and then like, a case where there's just a floating point number. So that's like a num with like 3 variants. And I can probably generify some of those. Like I might have nodes that take like a list of floats, and that could just be a parameter type. means, so it's not super generic. I'm going to end up with like several different special cases there. And the parameters are still like each thing that takes a parameter has a little DSL for specifying what its parameters are. And so that is likely to make the language appear inconsistent. I might be okay with that though. Okay, I think I'm going to go in that direction, which means, what do I need to do? I need to find, where is my lines? Okay. So I need to add a new thing. So this is a bridge node. And a bridge node has the name of the input node, the name of the output node, so two strings. I know what the type is, so it doesn't matter. In this one, that second string represents the constructor name, but in this one, it's always going to be one type. And that's all I need. It's just those two things. Okay, so that solves one problem, and let's just go ahead and do that. Bridge node. Already forgotten what I called it. I think that. So it's in out. Those are the names of the two ends of my bridge. And then don't need this anymore. That, and then don't need that. So this stuff actually got simpler. Always a nice direction to move. But that means I've broken something in reparse. I need to go fix that. So here... So what am I doing here? I'm just making a map of names to types. So I think I actually need that trim. That's left over from when I had a sloppier parser. Node, and it is a bridge in type. Probably need to string this. And then there's going to be unbridge out. I don't expect an answer. Yeah, even worse, sir. Oh, poo. But now I can't do that because the lifetimes aren't going to work. Ugh. Okay. I just cloned this. And now it's no longer references, now it's just strings. And that's fine. Okay. Let's get simpler. Okay. So that gives me the stuff where I have a map to look up nodes, which actually can't remember why I needed that, but I'll just assume that it's a good idea. And then here is where I'm actually building stuff. So, again, don't think I need that anymore. So this is my other case where I've already built the node. So I'm gonna have to come back and delete that, but we're not worried about that. And this is dynamic stuff. What happens if I had a thing that was a dynamic node and it's now a bridge? Or the vice versa. I think it just gets dropped when I do my cleanup earlier. So I'm not going to worry about that. I need to fix this anyway, because this actually destroys the state of dynamic nodes on every load, which is awkward. Okay. Okay, so here's the case where I'm actually doing my construction. So this is more or less what I need to do. Just the inside of this, basically. Okay. So let's set up for that. So line, bridge nodes, in node, out node. That's what I used earlier. Try and be just a little bit consistent. Okay. And then to actually build those nodes, I need like that. So this is what's going on here is I have an array that's shared across anything in the current executable, and they can all like it's a registry of whatever modules are available, and that's what that macro that I was talking about at the beginning is stick stuff into this registry, and you can actually anything that's linked into this executable can actually register stuff into this registry. And I'm using what library am I using? LinkMe to do this. It's just convenient. So what this ends up being is it's effectively a lookup table of these constructors, and I'm just going to look into that. But what is I? Oh, it's a list. So previously I built a lookup table of indexes into that list. Okay. A little bit more complicated. Okay. But here we know what our type is. And the type is no, the type is no. Type is nothing. I don't need that because these are not dynamically these are not things in that registry. I just know what it is I'm making. Okay, so what I'm making is I'm making a bridge. So that's 2 ends. I specify a default value. I probably don't actually need to do this because I think it's safe for it to always just be 0, but whatever. So I wrote the code. So those are the 2 ends of my bridge, and then these are the names I'm going to give them. Bridge doesn't care about sample rates. That is not its business. So this is type is again, these type names they're really not that important. They just need to be mostly unique. They matter for reloading the graph and for no other reason. Okay. And I think that's all I need to do. So now I have my matched pair of bridges. Okay, let's just see if that compiles. No. Okay, what am I doing? And then And you're complaining the trait bound borrow string is not satisfied. And that is because I have this two references deep, and now it's not 2 references deep anymore. Okay. And this is no. And this is going to be. Oh, how do I build these? Just a constructor, just a new constructor. Okay. Or I already have a method for this, which does the box implementing. I think that's the right way to call it. Yeah. Cool. Okay. So that's that, I think. So now I'm left with this other case where I have the parameters that I need to deal with, and that's going to be the more complicated one. So the way I think I'm going to approach that, at least for the moment, is like this. I think this is a good idea. So let's just try it out. Drive debug, because it's always nice to be able to print stuff. And then this is node parameters. And I'm just going to have a variant on this for everything that might have parameters. So what are my or every type of parameter, I guess. So this is a sequence pattern is one case, and that's going to be a subsequence. And then there's at least one case where it's just a number. And that might apply to several different nodes. And then there's my automation sequence, which is a vec of interpolations, I think. I think that's the right thing. No, that doesn't debug. That should debug. Let me just fix that real quick. Maybe there is no reason for this not to be debug. Okay. And then I have the sum sequence, which, let's see, I don't actually remember how that one's structured. It is this weird array thing. Fine. That is probably not really the right thing to do, but that's the way it is. So, and that is a sum sequence. Whatever. Okay, so I think those are currently all of my cases where a thing takes parameters. Eventually I want to generalize this to just like whatever parameters I might need, and ideally in a way that leads to sort of consistent syntax. But just for this first pass, we're gonna leave the inconsistent syntax and just do this, and it's gonna be super fine. So now instead of that, this still takes an optional thing, but it's a node parameter. I mean, I can represent like the now I can't tell if it's right or not. Whatever. Wouldn't be the first time I have misspelled stuff in my code. Cool. I mean, I could represent the none case here and have a void or no parameters variant. But I don't think that's any clearer. Yeah. Okay, cool. So now I need to go to the places where I do this, which should be showing up the errors now. Like that. Okay. So now instead of building this node, which is not what I want. But now this forces me to have a special case for each of these constructors. Okay, whatever. I'm just going to live with that. And it will be okay. So some sequencer, I'm just going to have code elsewhere that checks for that and does a thing. And that's fine. And then, but instead of the node, now it takes a parameter node parameters. And these are that. Cool. And then there's going to be a thing for automation, which is the same deal. And it's going to be that ES thing, which I think has already been converted to the right thing. So it's and it's going to be yes. I don't need to do that at all. What did I call it? Automation sequence. Good for them. Cool. Okay, and there should be one more. Here it is. This is my pattern sequence, and this is going to be the exact same thing. What did I call this one? I'm going to try and be consistent-ish. Okay. So I think that handles all my cases. Okay, but now I need to change how I'm building these nodes, and that's in parse. Here. So now I have parameters, and these are potentially optional. This case no longer exists. Delete that. And now I know that. No, I don't like this. Okay, whatever. Can keep doing it. So now I have to have a switch in here that's like, if the type is one of those types that I know needs special handling, I do it here. Otherwise, I call my generic constructor. So let's see. Let's do makes sense. So I'm gonna match on my type, and then my types were some sequence. That's gonna be a thing. Pattern sequence. That's gonna be a thing. And automation, that's going to be a thing. Bridge I've already got handling for, and then everybody else is this. Okay, I am not happy about that, but why is everything red? Okay, cool. Okay, so let's just double check that I actually got these names right. Already, the answer is no. No twice. No 3 times. Every single one. Okay. So what did I actually call them? Automation? That is what it's called. Sequence. Some sequencer, and pattern sequencer. Okay. Sequencer and pattern sequence. Okay, cool. What is wrong? You expected sounds to register. No. Oh, as master. Yeah, okay. Okay, so now these are the guys I need to handle. In each of these cases, there must be parameters, and I'm just going to panic if they don't exist, and someday that will annoy me enough that I'll stop. So let rams equal systems wrap. No, I can do better than that. If let's gonna be some and this one has to be a sum sequence. So node enters sum sequence that. Okay, so that pattern will only match if there are parameters and they're of the right type for this branch. Otherwise, because I do need to stop at that point, and I will think about better error handling later. Okay, so now I have enough information to actually build this node, and it's going to be sort of the same thing I did for the bridges. I'm going to build my node, and it's going to be a sum sequence new, and it's going to take the, I think, a reference to parameters. It's probably already a reference. No. What's it called? Sequencer. And that's fine. Cool. Okay. And then I'm going to stuff that into the graph. So add box node. It's not boxed yet. Nodes. Clone. And then, yeah. Okay, and we're done. So this pattern is going to repeat for each of my special cases. Just the thing itself changes. So this one is a pattern sequence. You can hopefully are cringing like I am cringing at this like repeated special case boilerplate. Obviously there's a better way of doing this. But I'm gonna figure it out later. Because I just want this to work. Okay, and then this one is called I think. No. What did I call it? The automation sequence is automation sequence. Because it is a sequence. But the node is called an automation node. I think. That. Cool. Okay. So I think that handles my cases. And now I think I'm back to where I was before, but with like all the information I need in the right place to actually do the code generation, I think. Let's just make sure we compile and we don't. Constant, that was the case I missed. I knew there was one more. It's just that it was in a different place. Okay. It's not actually inside the parser, it's inside the expression stuff, which is fine. Okay, so you're the same thing as the others, except you are a node parameters number, and the number is the and then here I have an additional case, and I think it's going to be exactly the same as the other cases. It's called constant. With a uppercase C, I think. And you care about number. And you are a constant. And do that for the constructor. And the actual value. Okay. And it was capital C. Okay. Not that. Oh, poo. Okay, that's fine. Cool. Okay, so now at this point, I'm actually not recording sound from the computer, so you won't hear this, but I'm gonna see if one of these things runs, and it should. It should sound exactly like it always would. And you're going to have to take my word for it that it does. Okay, so now we're back to where, like, everything works exactly as it did before, but better, which is always a good start for refactoring. So I think that's where I'm going to end for this pass, and then I'll come back in another video to start working on the actual code generation stuff. So that is it.